In this HVAC training video, we're going over some of the reasons why we're switching from R-410A to these new lower GWP refrigerants such as R-32 and R-454B. In this video, we're going to be covering a lot of different things, from why this is happening to how these differ from R-410A to the differences in the bottle, differences in some of the systems. So stay tuned as we go through each of the details. So why this is happening is that the AIM Act was passed in Congress in 2020, and that's in the US, and that's to regulate high global warming potential refrigerants. And so R-410A falls under a classification that's very high as far as global warming potential. And that means that if there's refrigerant leaks and it leaks out, that could basically warm the earth more or faster than these lower GWP refrigerants. And so there's a benchmark set of 700. So anything that's higher than 700 global warming potential is basically regulated. So there's going to be a sell-through period for new split systems that are factory equipped with R-410A, and so they can no longer be installed after January 1st, 2026. And so that's that 1 year mark. But if you have a packaged unit or a smaller, basically self-contained unit, those are able to be installed up through 2028. And so we're going to see how that plays out, if there's any rulemaking changes that occur in reference to that. But you're going to be able to keep R-410A systems alive because the parts for R-410A systems, such as TXVs and other things, are still allowed to be manufactured through the life of a system that has a high global warming potential refrigerant, such as R-410A. So now, what's the difference here? So this one has 2090 or maybe 2088 global warming potential, whereas R-32, that has 675 as a global warming potential, and R-454B, which is also known as XL41, that's from Chemours, this one right here, basically that one has 465 as a global warming potential. Now these two are classified as A2L refrigerants, and so R-410A is classified as an A1. And what that means is there's no flame propagation with this. Whereas with these refrigerants, there's just a very slight possibility of flame propagation. That doesn't mean that there's any flammable refrigerants or anything like that in these. So basically R-32 is in R-410A. It's actually 50% of R-410A. So you have R-125 and R-32, and that mixture makes it an A1, which has no flame propagation. And so that's what we've been using for years. But the fact of the matter is, because this one had such a high global warming potential, we're switching to the lower global warming potential refrigerants. And so you have this one is under 700 at 675. But anyway, so R-32 has been used, say, over in Europe for over 2 decades in mini splits, in heat pumps and things like that. So a lot of the tools that have been used, you know, there was no problem really with these R-32 systems that were used over in Europe. But basically what we're trying to do is limit the global warming potential even lower in the US. So Chemours decided that they wanted to get a global warming potential that's lower than 500. So that's why they went with a mix of R-32 and R-1234YF. And if R-1234YF sounds familiar, that's the refrigerant used in automobiles starting as early as 2013. And so that's a pretty common refrigerant. So you have that refrigerant and R-32 that makes up a mix here. So 68.9% of this R-454B refrigerant is actually R-32. And only 31.1% is that R-1234YF refrigerant. And so that mixture allows this to have very similar operating pressures compared to R-410A, and similar with R-32 as well. And so where R-454B might have just a slightly lower pressure than R-410A while the system is running just slightly, you're going to have R-32 is going to be just slightly higher as far as its running pressure, but it's going to be very similar. Now that does not mean that you can just drop this refrigerant into an R-410A system, because that system's compressor is made to pump R-32, or it's made to pump R-454B, because you have to think about the flow rate of these refrigerants is different than R-410A. It has to be optimized for that specific refrigerant. As well, A2Ls, those systems, any system that has, say, more than 4 pounds of refrigerant, is going to have a refrigerant leak detection sensor. And it's going to be not only systems that have 4 pounds and more, but it's going to be ones that basically, it has to also be calculated with the room volume as far as a dilution of refrigerant to air if there were a leak. And so you might see other systems that have less than 4 pounds having these A2L refrigerant specific leak detection sensors. And they're going to be mounted over at the, say, the evaporator coil at the indoor unit at the lower part. And those could be, say, they could be listening for an audible sound change. It could be potentially just a chemical specific thing. It could be thermal conductivity. It's like there's a bunch of different sensors that can be used as far as that goes. And so those will be manufacturer installed in systems, and I'm sure they're also going to be able to be field installed as well. So they're going to require those leakage sensors, and what happens is if it trips due to detecting a certain parts per million of an A2L refrigerant, then what's going to do, it's going to shut down that compressor outside and it's going to turn on the fan motor. And the whole point is to dilute the refrigerant leakage with the air. But if it continues to go off, there might be a lockout or something like that, but that's all going to be specific to that manufacturer. And you have to read the manufacturer's literature in reference to that. So they're all going to be, slightly different. Now, in reference to the bottles, there's a couple differences. We did, or we are allowed in the U.S. to use disposable bottles. That was a recent rule change over the last year. So for these new A2L refrigerants, we don't have to use refillable bottles. However, we do have left-hand threads at the port right here instead of right-hand threads. And that's just to distinguish that this is an A2L refrigerant. And so you're going to need a left-handed adapter. It's going to go from left-handed to right-handed. And of course, if you're screwing a hose onto that, you could accidentally unscrew it the other way and cause a refrigerant leak. So some manufacturers, some tool manufacturers, have made hoses with left-hand threads already on them. And so you can just attach them right onto the bottle. Another difference is you're going to notice that there's no color change between R-32 and R-454B right here. So what they're now doing is, because there's so many refrigerants on the market, they're not doing color designations like they did with R-410A and R-22. And so you're just going to have a regular colored bottle, and you're going to have the refrigerant posted right on the side of the bottle. So it's right there, it's right here. You're also going to notice there's going to be a red stripe anytime that it is a A2L refrigerant. And so there's also going to be instead of a burst disc, you're going to have a pressure relief. So it's only going to allow a little bit of refrigerant to escape if the bottle got overpressurized due to high heat, maybe in, say, the service truck or something like that. If it was a black service truck and it was parked and it was really hot, it could potentially pop that little relief valve and open up until the pressure reduced in order to not spill out all the refrigerant like this, which was a burst disc for the R-410A cylinders and the R-22 and things like that. So there's a few bottle changes, those 3 bottle changes as well. If you noticed, R-22 was 30 pounds of refrigerant inside, R-410A is 25 pounds, R-32 and R-454B, those are 20 pounds of refrigerant inside. Those refrigerants all have different densities as well as far as their weight in liquid form, but just keep that in mind as well. But the bottles look very similar in size, even with the poundage differences. But once again, the refrigerants are different in weight. For instance, R-32 ends up weighing less, so you'd have like more refrigerant in this bottle than other refrigerants such as R-410A or R-22. Now, in reference to these bottles and in reference to refrigerant charging on systems, we always set this bottle upside down as far as how this refrigerant is supposed to exit the bottle, because it needs to remain as a 50-50 mix. And so it can do that as long as it's in liquid form, which then is going to be coming out of the bottle in liquid form. Now, R-32 is only a single component refrigerant, so it can get charged as a vapor out of the top or upside down as a liquid. Of course, when we're breaking a vacuum and trying to charge a lot of refrigerant into a system, you're always going to flip the bottle upside down and charge it as liquid into an off system that is vacuumed down to try to weigh in the correct amount of refrigerant into that system. But for normal charging, R-32 can just be charged as a vapor. And our compressors breathe vapor refrigerant, so that makes it really easy. As far as R-454B, this is going to have to exit out of the bottle as a liquid. It's going to have to come out as a liquid, and so you're going to flip the bottle upside down, and it's going to come out as a liquid because all the liquid would be at the bottom of the bottle. Now, as far as topping off systems, what you need to think about, so say there's a refrigerant leak and it's leaking at a valve core or something like that. For R-454B, you're supposed to be able to add a little bit more refrigerant, even though there's two refrigerants in this bottle and then in that system, and they could leak out a little differently than each other. By adding a little bit of refrigerant back into the system, it should keep the mix primarily the same as what it was before, or very close. And so you can read a little bit more on Chemours' website in reference to that refrigerant, but they're recommending that you can go ahead and just top off a leak. Now, here's the thing. We don't go around and just finding leaks and just adding refrigerant to them. We are always leak searching for the refrigerant leak. And the reality of it is, if you had a leak at the evaporator coil, the refrigerant sensor is going to keep going off, and it could lock out the system, or it's going to continually turn on the blower motor. And so you don't want to be one of those technicians that just goes around and just adds refrigerant to systems. We need to find the refrigerant leak, and so you can use a variety of refrigerant leak detectors in reference to this. And a lot of times I'm using an ultrasonic leak detector because it's not refrigerant specific, but you can get refrigerant specific detectors. Infrared leak detectors and things like that work well, and so just keep that in mind. Now, as far as R-454B is concerned, on a PT chart, you're going to have what's called bubble and dew. And what that really means is the saturated temperature is not the same in both when it's coming, like basically changing into a liquid and changing into a vapor. So it changes into a vapor at the indoor coil and changes into a liquid at the condenser coil. So let me show you what I mean. This is a SMAN 380, and so we have R-454B selected at the top. And you're going to notice right here at zero pressure on both sides, you have a different saturated temperature. And so on the vapor side, you have 56.5 degrees Fahrenheit. That's a negative temperature, by the way. And then over on the liquid side, you have a negative 58.3. And so it's not going to be the same like it was with R-410A. So R-410A had a temperature glide of only like 0.3 degrees. And so R-454B is about 2.1 degrees as what's called a temperature glide. So as long as you're using either a digital manifold that's converting to saturated temperature, or you're using standard gauges and using an app like the refrigerant slider app, you can, if you measured the pressure with the refrigerant slider app, or you are using probes and an app, it's going to be able to convert the pressure to the correct saturated temperature in order to measure both superheat and subcooling. We're still checking the charge or measuring the refrigerant charge and adding refrigerant in the same way that we did with R-410A. And so let me just show you with this refrigerant slider app, you can select either bubble or dew. So right here on the app, we're measuring 107.5 PSI, and that right now it's selected on dew, which is the pressure converted to saturated temperature at the indoor coil. So that's the pressure that you'd measure on the large suction line. Now, if you were to switch this over to bubble, the temperature is going to change. Instead of 40.25, it's now 37.91. And so you want to make sure that you have the correct one selected. So bubble is used as your liquid pressure converted to saturated temperature. And so for instance, if you measured a pressure on the high side of maybe 345.9, then your saturated temperature will be 110. So you want to make sure that you have the correct thing selected up here. So if we were to accidentally be on dew, it would tell us that we're at 112.3 as a saturated temperature in the middle of that outdoor coil. So that could throw off our subcooling measurement by like 2 degrees or 2.1 or something like that. It's actually a pretty significant amount. But as long as we use either digital tools or probes, we're not going to have that confusion happening, because within our app, it's going to be able to calculate the saturated temperature correctly. And so to learn more about that, check out some of our refrigerant charging videos and check in the charge videos to understand what saturated temperature is. We also have our books available as well, so that you can understand more about those over at acservicetech.com, and those books are at Amazon. Now, another concern that technicians have is in reference to the tools that are needed for any work on A2L systems. And so tools, like, they're not going to really change much. Any of your normal installation tools you can still use. The considerations have to do with your refrigerant leak detection devices, your recovery machines, your vacuum pumps, things that they want to make sure that there's no open sources of a spark when you're using or recovering or vacuuming systems that have A2L refrigerants. And so that's up to the tool manufacturers to kind of almost like regulate themselves, and so at least presently. And so they're just making sure that their motors and different things are all sealed and away from where the refrigerant pumping components are located at, where the vacuum pump components are located at, so they're just separated so as to make sure that there's no problem. But as far as the rest of the vacuum procedures are concerned, they're all the same as normal. So we want to make sure to pull down and hold below 500 microns, but realistically, when we're pulling a vacuum to dehydrate the tubing of a system before we add refrigerant into it, we're pulling those systems down to like 100 or 200 microns, and then we're isolating the vacuum pump wall, reading on the vacuum gauge during a decay test, and making sure it doesn't rise too high. So if we shut the vacuum pump off at around like 180 or 200, it shouldn't rise above, say 300 or so. Basically, you don't want it to continue to rise, but it's showing the standing vacuum test or the decay test with the vacuum pump off, and so basically we need to dehydrate the system in the exact same way. We need to break the vacuum with refrigerant in the exact same way. As far as recovery levels, it's the same process as far as recovery of these refrigerants. Now, we are waiting to hear, as far as the recovery bottles having maybe a red stripe and having a left-hand thread. We have not got kind of final confirmation of what that's going to be like yet. But there will most likely be A2L specific recovery bottles, and just like before, you don't want to mix different refrigerants in a recovery bottle anyway. You keep R-410A recovery bottle as R-410A inside, R-22 as R-22 inside, and then we are sending them back to the distributors to send them to the reclamation facility so that they can recycle that refrigerant or reclaim that refrigerant into new refrigerant bottles. Now, one thing that will change as far as working with these A2L refrigerants are pump downs and recoveries. So after you're done doing a pump down or after you're done doing a recovery, after that happens and you're down at your, say, 0 PSI level for, say, residential heat pumps, you're holding below 0 PSI with the recovery machine off. After that's done, and say you're going to move the piece of equipment from one location to another, or you're getting ready to braze on that again, you need to purge the system with nitrogen. And so you might be doing that at, say, like 15 cubic feet per hour for maybe 2 to 5 minutes. And so that's going to kind of push any A2Ls out of the system to make sure that while you're brazing, there's not an accumulated amount of A2L refrigerant in the system when you're going to rebraze the system again. And so it's really important that when you're doing your recovery process, you try to maybe warm the system when you're recovering to make sure that you are getting all the refrigerant out of the system. I like to turn the indoor fan on to kind of put a heat load at that indoor coil. You can put a heating blanket around the compressor because there's usually refrigerants kind of stuck in the refrigerant oil in the compressor, and so you're trying to heat that up, trying to get all of it out. But the big object here is that you need to purge the lines with nitrogen before you braze. So we are going to purge them at, say, you're going to follow the manufacturer's literatures on this, but usually it's around 15 CFH for about 2 to 5 minutes, and that's for small systems. But while you're brazing, we always have flow nitrogen between 3 and 5 cubic feet per hour while brazing. And remember, you're not pressurizing the tubing while brazing, you are just flowing it through. So it has to have an entrance point and an exit point in order to make sure that you don't have any oxygen in the lines while brazing. So you don't want any oxygen, you don't want any A2L refrigerant in the line while you're brazing. So that's very, very important. So that is something that you definitely need to take into consideration before you go to braze in an existing system. If it's a new system, you're going to do your standard, you're going to purge at 3 to 5 CFH, and the whole point of that is to reduce any oxidation from occurring inside the tubing that could end up clogging maybe a strainer screen, like right in front of the TXV, or clog the filter dryer, or it could reduce the lubrication at the compressor. Remember, inside the compressor, it's just oil. There's no like roller bearings in compressors. It's all just seals basically, and you just have just your oil between two metal parts. That's your seal. And so you don't want basically black carbon soot, which is the cupric oxide that has formed on the inside of the tubing because you didn't flow nitrogen while brazing. It's very simple, it's very quick, it's not a big deal. So that's some of the considerations. Of course, you could do press fittings and things like that as well, but you got to make sure that that tubing is exactly round if you're going to use those press fittings. You don't want to put it on a tube where it's like in a bend or anything like that, or it's squished down and things like that. So just keep these things in mind when you're working with the A2L refrigerants, and I'm going to have a bunch of links to EPA documents and things like that in the description section below. And remember that all this is subject to change as far as the EPA rulemaking bodies. So there's a bunch of different things that you can do to get ready for these new A2L refrigerants. And the biggest thing, read that manufacturer's literature for the equipment that you're installing. And if you want to learn more about HVAC, make sure to check out our website over at acservicetech.com and take advantage of all of those free articles that are there. We've got quick tips, we've got calculators, we've got quizzes in order to test your knowledge. We also have our books available, so make sure to check those out. We also have our video lists that go along with our books. And so there's a ton of resources, and so you just want to always be investing in yourself to be more valuable so that you can support yourself well, or your family well, or your future family well. So hope you enjoyed yourself, and we'll see you next time at AC Service Tech channel.